the underlying thing is that you're building the chips that make that possible. Right?
Yeah.
And I've seen you compare it in particular to like the difference between dial-up and broadband,
Yeah.
right? So everyone had this experience, those of us who are old enough, had the experience of suffering through dial-up, internet and thinking like, wow, the internet is amazing, but it takes forever for each of these images to load. And at first you think like, okay, well, because we have access to all this information, it's wonderful and it's great. And then you get broadband and suddenly your eyes open up and you realize there's so much more possible because of this. So your argument here, and that you believe your chips are going to enable, is creating the same sort of epiphany. And so what do you think is going to be enabled when you have chips like that enabling much faster AI?
Better retention. So as some people are aware, retention is not so good on these large language models. A large part of that is how long it takes for these models to run.
And just really quickly, in terms of retention, just for people who
Yeah.
aren't as familiar with AI, explain what you mean.
So when you go to a website, do you come back? Do you engage? Do you buy something? And one of the top factors in retention is the speed at which the site loads, gives you results. Interestingly, on desktops, every about 100 milliseconds or so of speed improvement improves the conversion rate about 8%. When it comes to mobile, I think it's something like 40%. It's crazy. Mobile, people are even more impatient. And so speed is crucial, and it is one of the reasons that engagement is so low.
And so what is it that your chips actually do? Why is it that they're able to be this fast?
We've designed a completely new architecture. My background, I actually created the Google AI chip that now most of their AI software runs on. And that chip was different than GPUs, but GPUs have since copied a lot of what's in it. For example, the tensor cores that are in GPUs were actually spec'd by Google. The chips that we've designed don't have external memory, so you heard a little about that earlier. And also we can connect a large number of them. And so the way to think about it is a factory. So a factory is not a great way to build one car. But if you're going to build 1 million cars, it's the most cost-effective, it's the fastest. You're going to get your car from inventory in to out faster. It's going to be the lowest energy. And so the demo that you saw, which you only saw for about a second, but it finished the answer, that was actually running on 576 chips in our data center. But because it's so fast, and because we can do a bunch pipelined and batched, we get very, very good cost efficiencies and power efficiency. We're about 10x better than the latest generation of GPU in terms of power and in terms of cost. And of course, you saw how fast it was.
And so, when people talk about AI and chips powering AI, like the conversation is always around the GPUs and sort of what's happening there. Obviously it's turned NVIDIA into this massive giant of a company. Is it, are you just presenting a different vision with the chips that you're creating? Is it, do you have to convince the world that your approach is a better approach, or what's?
No, so we don't actually overlap market-wise with NVIDIA, AMD, or Intel. So those companies are building GPUs. GPUs are amazing. They've been around for 30 years. They've got a great legacy, and they're actually how we got here. They're how you train these models. When you're training a model, it can be done in parallel. It doesn't really matter how quickly. You're going to run this training session for over a month. What do you care if some portion of the computation takes a little while before you get the answer? It's masked behind all the other computation that's going on. In large language models and other generative AI, such as diffusion models, but in particular large language models, you can't get the 100th token until you've gotten the 99th. Right. There's a sequential order to it. So anything that's sequential has a real problem with these completely parallel designs. We have a lot in our architecture, especially the way that we do our networking, that enables us to complete tasks very quickly and then sequence them. And so that's why that was so fast.
So I think it's important for people to understand that the sequencing issue is kind of a key aspect of what it is that you're doing, right? Mm-hmm. So you know, I know another analogy that we spoke yesterday, and you sort of gave me this analogy, which I thought was really interesting, that sort of gets to the sequencing issue, was sort of comparing like the Hertz model versus the Uber or Lyft model, right?
Yeah, I think that would be confusing in this context.
Okay.
So think of it this way. When you're playing a game of chess, you can't figure out what your 100th move is going to be until you've figured out the 99th, right?
Right.
And language is the same. The words that you select determine which words can come next. As was demoed earlier, you know, I ate for breakfast. I can't say whiskey. I mean, I could. That would just be very rebellious, right? But I can't because I said ate.
Right.
Now, if I said I had for breakfast, I could say whiskey or whatever I want. Pancakes, doesn't matter. And so these word choices have a huge impact on what comes next. And they're actually a bit of a, for this more technical audience, they're almost a dynamic system in that there are some significant repercussions that occur down the line. So anything that's sequential, these models are great at.
So there are interesting questions raised by this. We've had, you know, we had a discussion earlier today. There have been a few discussions today about the risks and concerns about AI in terms of like generative AI, you know, sort of running amok kind of issues. Do you have concerns that, you know, if you can speed things up 10x, effectively make it cheaper, are you enabling more of the concerns, or what?
So we're very, very, very focused on being responsible in whom we sell to. We are fabbed in the US. We're careful about whom we're willing to sell to. There are countries that we will not sell to. And the way that we put it is we will not sell to the PRC or any of their companies that, got it, in part because we want to support the people there. We don't want to give this capability to an authoritarian regime, right? It's just not the right thing to do. The reality is extra speed adds more capability, and I could ask the same thing about broadband or dial-up. If we give people broadband, can they download malware faster that they can use? It's a tool. One of the cognitive dissonances that we have around AI is we treat it almost as if it's magical and it doesn't obey the laws of physics, and it does. So tokens are probably the new oil. And the way to think about this is you're not going to magically build a factory that's going to outproduce the competition. You still rely on finite resources like oil or coal or solar or whatever it is that you're building. And in this case, it's the number of tokens you produce. The AIs will not go run amok unless you're giving them tokens. That's just not going to happen. I think the real issue is, just like with how Italy and France built the start of the Industrial Revolution, and then you know, England won because they had the cheapest coal, what you're seeing is just because you're ahead now doesn't mean that you will stay ahead. And just having invented the technology doesn't mean that you have the cheapest tokens. So I think this is working now. So we're going to go back.
All
right.
Give Elon the advice that he needs.
Oh, yeah. How about tell me about the safety concerns about AI. All right. So that was streamed over my mobile phone to the data center. So you saw a couple of jerky moments there. However, that was 696 tokens produced in 2.15 seconds. That is Llama 2 70 billion, which is the largest model that Meta has released to date, with the full context length. For comparison, very often when we show this to potential customers who are running this model, they're getting between 9 and 30 tokens a second, depending on what they've done. One of them actually built a 256 GPU system to get their performance up, and they were getting 30 tokens a second on this model. This is 328 tokens per second. What are 5 ways to improve your answer? Okay, apply those. And while we're at it, let's see if it can translate. So translate that to any languages? German. I heard German. I don't know about the quality, not our model, but relatively speedy translation. I heard a wow, thank you. All right, let's go back to...
Yeah. So to go back to the, now that everyone's seen it and sort of how fast it is, and to go back to that concept of the analogy of like dial-up to broadband, obviously the switch from dial-up to broadband actually enabled a whole bunch of things. And sometimes it was things that people didn't expect or didn't imagine. Some of it people sort of predicted, oh, if we could have faster, you could do video, for example, or things like that. What is it that you think, having this kind of speed with generative AI, what does it enable?
Yeah, so when I said that we're not really overlapping with the GPUs, so GPUs are sufficient for training and they're sufficient for batch processing of things overnight. So if you want to generate a bunch of emails overnight, if you want to do something like that, it's fine. Code editing is not something that you want to be sitting there for a very long time. Other use cases are tutoring people who are on the phone, so we've seen that from customers. Generating websites is another use case that we've seen. Those are all very latency sensitive problems. So we don't see ourselves overlapping at all with what anyone else is doing. Now, some of the things that can be enabled, one of the things to keep in mind is that quality and speed can be traded off. And there's the obvious one of you can run a larger model and it runs a little more slowly. So a lot of people have asked us, well, like one example was there was a group that wanted to train a 300 billion parameter model. I showed them the demo and they said, great, now I can train a 300 billion parameter model. I'm like, we're not really focused on training. And their response was, we could train the model, that wasn't the problem. We just couldn't deploy it. Now you can do this fast enough. Another way to do it though is that reflective capability. So these models are good enough to notice that they can improve their answer. One of the most astounding things about these large language models, they've got all sorts of problems, and if you look at the quality of the output, you could be like, I could do better. But could you do better if you couldn't hit the backspace? Think about that for a moment. These models are actually doing this stream of consciousness. They're just going token, 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 token. They don't go back, they don't edit.
Right.
When you actually ask them, what are 5 ways to improve your answer, now apply that, it's like giving them the backspace. You don't do that today because they're too slow. And that has a huge improvement on the quality of the output.
So you could even build that into different models or different tools.
Automatically.
Automatically, because you have the speed, and the results would still be coming out effectively as fast as other models today.
And actually faster.
Faster.
Yeah.
So, well, I'll ask the question. You have this demo that everyone can see, but you're out here. You're a chip company. Is that web interface a product?
So the web interface that you saw is going to be our new website. So I'll open that up again just to point out one thing on there. Here you see continue to Groq, and that takes you to our normal website. But why would you want to search around a website if you could just ask the questions that you have, like, what products does this company sell? How do I get technical support? That's much faster than clicking around and searching. It's also easier for us to update. We can insert images and other things like that, but this is faster and better. So that's actually going to be our website. So you're going to be able to get access because we're just going to make it available to everyone. And it runs the standard Llama 270 billion.
Right. So and Llama is the open source model that Meta released.
Yeah.
Sort of.
It's actually fully released now.
Right.
Fun fact,
okay.
Everyone gets a little confused on the licensing. They're like, oh, if you ever get to 700 million monthly active users, you can't use it. Only at the time of release. So if you grow larger than that after, you can still keep using it.
Really?
Yeah.
Okay, I didn't know that.
Yeah. So unless someone has 700 million active monthly users at the moment, you're fine.
Interesting, very interesting. So, where do you think that the underlying technology that you guys are building, where's that going? Where do you go next with it?
So we're ramping our production. The demo you saw was running on 576 chips. We're definitely going to have 30,000 deployed by the end of the next 12 months. We're hoping to get to 100,000. And
these are deployed where? Sorry.
So currently, I don't know if those were in our Washington State data center or our Mountain View data center, but we're going to be deploying them in those 2 locations and a couple of other, but mostly in the US for now.
But so these are being deployed in data centers that you control, right?
Well, we rent the space.
Right.
So we don't build the data centers,
Right,
but we
right.
control the physical space, yes.
So I'm just saying, as opposed to organizations buying the chips and deploying them themselves.
So we do sell the systems.
Right.
There are customers who have already purchased some systems, and there are others who are interested in buying larger volumes. That is a very interesting, from a business point of view, it's very interesting because it's, for us, non-dilutive capital. We're a startup. We still think of things as investments, and we're like, oh, when you sell stuff, it's non-dilutive capital. That's awesome. But the nice thing about that service you saw, so we have an API, and we actually have customers consistently benchmarking it. So like all day yesterday, I was having to give a demo of a smaller model because we have people benchmarking that larger one. That's easy, and anyone can just sign up and use it. It doesn't, I mean, in theory, we could sell $1,000 of tokens, and it wouldn't be a big deal.
But do you think the future for the company, is it selling the chips, or is it offering time on the machines that you've deployed within your data center?
So there's this concept of forward integration where basically you just keep integrating until people start buying all your stuff. And we have forward integrated from the chip to the system, our own networking, our own compiler, our own API. If someone buys out all of our hardware inventory, then we'll probably be happy doing that. But right now, we're getting most of our traction on the API side because there's a lot of customers who want the speed and are doing things that require it, and they can't get that from anyone else.
I wanted to go back to one thing because I think it's interesting in terms of, you mentioned that the chips are actually being fabbed in the US,
Right.
which is an interesting thing. It's becoming increasingly important, and it's becoming somewhat more increasingly common. But I want to give you a chance to kind of talk about that, like, where the chips being produced, and how did you decide to have them fabbed in the US?
So our chips are fabbed in Malta, New York, packaged in Bromont, Canada, and then we assemble the systems in California and deploy them either in Washington State or California. And the reason was, having started the Google TPU, I had a real concern about whether or not I was going to be able to place an order for chips and get them if they were in Taiwan. And this is not an issue that I think larger companies pay attention to, just like no one paid attention to the ability to get out of your lease if there's a pandemic, right? It's just too big of the bigger the issue, the less people think about it. We were concerned about that, so we did our first chip with GlobalFoundries, and our second chip we've signed to do with Samsung in Taylor, Texas, and our plan is to keep that on shore. And it's not even about, if something does happen. People are now starting to get concerned about what if it does happen. And they're trying to make some decisions about what they can do where either way they're safe.
Right, right. So we have about 4.5 minutes left, so I want to open it up for questions. We have the microphones on either side if anyone wants to come up. I'm not seeing anyone jump up yet. I'm surprised. So I can keep going forever. Okay, so in absence of questions from the audience.
I think we have.
Oh, do we have someone's running? Okay, go.
Hi, could you restate the performance advantage that you think you could get? So for example, on this particular demo, it seemed that you were doing 328 tokens a second, and a really good GPU system was doing 30. What do you think?
An almost comparable number of GPUs can get about 30, but people don't typically put that many GPUs together. That's very difficult.
Okay, that's exactly what I'm getting at. So the GPUs have some sort of limit. We'll call it 30. I realize it's not a limit, but what is the limit on how fast you could do this? Because it seems like you can scale.
Well, we won't get performance improvements forever as we scale further. But as I said, when we got to 100 tokens a second, we're going to get a little bit faster. And so that was 300. So I'll say we're going to get a little bit faster.
Okay.
Now we have a question over here.
You're hooked up to Llama now on your website. Are you going to hook up to any other engines as well?
So we already have Falcon 40 billion, Jace, and another variant of Llama called Code Llama working. And with the exception of Code Llama, each of these 3 models is a different code base and had to be compiled independently. And so they're all different, and each one of them took a very short amount of time, less than a week to get running. So if someone has another model they want to run and they want to pay us to run it, we can do it.
Is your chips specific to LLMs, or can you apply it to other areas of AI? And what are you thinking about next?
So technologically, our chip is not specific to LLMs. It's just very good for them and anything that's sequential. However, from a marketing point of view, we call it an LPU chip, for a language processing unit, because it is so fast that at that task, and it's such an important thing right now that we wanted to get as much attention as we could. We can do other things. We have sort of style transfer for images working. We've done graph neural nets. We've got Cubo running on our chip, which is a quantum, or is typically used to do quantum-like algorithms, but it's an optimization algorithm. So anything that you can write in PyTorch tends to run very fast on our chips, and most importantly, you don't have to break the problem apart. You just say num_chips equals, and then we compile across those chips.
How are you pricing compared to OpenAI and other API providers, given you have a premium offer with obviously exceptional performance?
Wow, it's almost like you've been in all of our board meetings for the last month. So when we first started, we thought, well, there's a bunch of people who need this badly. We have finite capacity. We could charge a lot. And one of the indicators to do this was people seemed willing to. And what we were concerned about was that people would actually start thinking that we're just really expensive and not want to use us later as we scaled, because we thought we could always drop the price later. The reality is our cost is 1/10 of that for a GPU, so we're more than happy to pass quite a bit of that back to others. And so we have the problem now that we sound too good to be true, because we are 10x cheaper, 10x faster, 10x lower power, and we can often get stuff running on our chip 10 times faster. If anyone finds that hard to believe, we are happy to charge you more so it becomes believable again.
And with that, I know that now there are more questions, but we are out of time. I know Jonathan is, Groq has a table out front, and so.
Heinlein,
Yes.
did you ever mention?
The name aspect?
So as a note, when I was poking fun at Elon there, he said that he got the name from Hitchhiker's Guide to the Galaxy. I don't think he's read these books. I know.
Stranger in a Strange Land.
Exactly.
He's mixed up the, yes. It's fairly incredible. But you misspelled it, so you left it open for him. So.
No, I didn't.
All right. Well, with that, we're going to get off stage. But thank you very much. Thanks to Jonathan.
All right. Thank you.